Welcome back. My name is Russell Cottrell, and in this series of videos, we're editing a photo in PhotoLine using curves. In this video, we're going to learn how to use LAB curves. PhotoLine can make curves adjustments in the LAB color space while the image itself is still RGB. Some very popular photo editors are not able to do this. PhotoLine is something of a pioneer, and when I got to the point where I was shopping around for another photo editor, LAB curves were what sold me on PhotoLine. If you're serious about photo editing, and especially advanced topics such as color management, you should know something about LAB. First of all, just like RGB or HIS or HSV, I pronounce it LAB because it consists of three channels, L, A, and B. And we're not talking about a laboratory or a Labrador Retriever. Its full name is CIE 1976 L star A star B star, but we don't need to get into that. First, a little basic science. LAB's claim to fame is that it is modeled on the nonlinear opponent color human visual system, and the math behind it is much more complicated than HIS or HSV. The L channel, which technically stands for lightness, is the luminance channel, and it should look familiar. Raising the curve lightens the image, lowering it darkens it. It's the A and B channels that are interesting. They are opponent colored channels, red, green, and yellow, blue. Raising the A channel adds a magenta red to the image, and lowering it adds a cyan green. The B channel is similar, but its colors are yellow and blue. This may remind you of the RGB channels in color blend mode that we looked at last time, but under the hood they're very different. It helps to visualize color gradients along the axes of the curves. L goes from black to white, A goes from green to red, and B goes from blue to yellow. Notice that all three curves have gray in the middle. How do you remember which curve does what? There are two mnemonics you can use. B for blue. The B curve is the one that has blue in it. And hot air rises. The hot ends, yellow and red, are on top. The actual numeric value of the A and B midpoints is 0, and the values of the ends, positive and negative, are theoretically unbounded. There are no maximum or minimum values. How they're displayed and used is implementation dependent. In PhotoLine's color editor, they go from -128 to +128. This leads to one of the odd things about LAB. Many of the colors at the extremes of the A and B curves are imaginary. They do not exist in real life. It's important to remember that when we start manipulating the curves. And notice that the A and B histograms are, in fact, both bunched up in the middle, around the gray point. Now, looking at the curve, it's important to remember this. The ends of the A and B curves are separate color components, at least to the eye. Luminosity has nothing to do with it, and the channels are not additive in the way RGB curves are. Pixels at the low end of the B curve have a blue component, and those at the high end have a yellow component. There's sometimes a misconception about this. The low ends of the A and B curves do not represent the shadows. That's the L curve. Outdoor shadows are, in fact, often blue, but that's beside the point. Each end of the A and B curves represents a separate color. When we move the low end of the B curve, we're manipulating pixels that have blue in them, not the shadows per se. On the A curve, the low end represents pixels that have green in them, and the high end pixels that have red in them. And no pixel contains both green and red, or both blue and yellow. This is the opponent color theory, and it's believed that, on an underlying level, this is how human vision works. So much for theory. To use the A and B curves, it helps to fix a point at each midpoint, the gray point that is the origin of the curves. And since this is something that we'll want to do again, let's record it as an action. Actions are what are sometimes called macros. For this, we will need to show the Actions panel. View, Panels, Actions. This button creates a new action, which we can name LAB Curves. We can also move it to the top for easy access. Now, when we select that action and hit the red Record button, everything we do will be recorded. Side note, it's surprisingly easy to forget to press that red button and have to do everything all over again, at least for people of a certain maturity. Layer, New Adjustment Layer, Curves. Select LAB and the A channel and place a point in the middle. It needs to be exactly in the middle. Holding down the Alt key while moving the point makes it snap to the grid. We can see the coordinates of the selected point or the mouse pointer in the number fields at the top. Side note, numbers may also be typed into the fields to place a point at a certain position. Double-click a field to select it. Then press Tab after typing the value. Note that pressing Enter is like pressing the OK button. Now the B curve. 50-50. When we're done, we hit the square Stop button. Now, to create an LAB Curves layer, we just select the action and run it. Let's delete the layer we just made and run the action. Our new Curves layer is right here. Let's look at the A curve. Raising the high end puts more red into the red pixels. Lowering it takes the red out. And below the center line, it turns them green. How's that for a curve? Lowering the low end similarly puts more green into the green pixels. Raising it takes it out. The green things are turning yellow because they've lost their green. On the B curve, raising the high end makes yellow things more yellow, and lowering the low end makes blue things more blue. You may have noticed this field up here that says spline. That refers to the mathematical equation of the curve. And they really are curves. Lowering one end with the center fixed like this raises the other side slightly. The only time I use anything other than spline is to sometimes change the A and B curves to line. Now, one side does not affect the other, at the expense of sudden changes in the slopes of the curves that may or may not be significant. This can be included in an action. Flattening the A or B curve to the midline effectively removes that color channel from the image. The values all go to 0. When we flatten the B curve, all we're left with is the green and red of the A channel. We can do the same for the A channel. Now all we have is blue and yellow. This, in fact, is something like human red-green color blindness. As a side note, techniques like this can be used to help create signage that has colors that can be seen by everyone. Flattening both curves takes all the color out of the image. We're left with just the L channel. What if we turn the L channel gray? Now, if we restore the curve, that ghostly image is the A channel in all its glory. We can do the same for the B channel. If we restore both curves, that is the color information contained in this image. Back to business. I'm going to hide the saturation curve we made previously so we can work on it in LAB. Since increasing the slopes of the color curves increases the amount of color in the image, we can use those curves to increase saturation. But by increasing the slopes of each end of each curve, we can saturate each of the opponent colors independently. And because the ends of the curves are mostly imaginary colors, we can increase the slope of the entire curve like this without doing anything drastic, at least up to a point. So to start increasing saturation, increase the slopes of each end of the curves. We can even use the arrowheads at the bottom of the graph. We can saturate the reds, the greens a little, now the yellows, and the blues. To target the values of the image a little better, we can select objects that need more saturation like we did with the HIS curve. We can start with the red carpet, select it, and raise it. There isn't much actual green in this image. Remember that foliage is mostly yellow and the green component is small. So let's skip it and move on to the B curve. Select the foliage, get a point that's kind of out there, and raise it until the soil starts turning yellow. Now for the blues. Let's select the sky and remember that to increase the blue, we lower that point. Now if we want to, we can go back and put a little green into the foliage. That's pretty good. To sum up what we just did, to increase saturation in LAB, increase the slopes of the A and B curves, and each half of each curve may be adjusted independently. It's like we have built-in color filters for each of the 4 opponent colors. Now, LAB saturation has a different character from using a saturation channel because moving the curves changes the hue as well as the saturation. But we can actually use that to our advantage. Let's look at the grass growing in the soil here. They both have a yellow component, but the grass has more. So if we select the soil and lower it, we're not only removing yellow, but we're separating the hues of the soil and the grass. Do you see that? The grass now pops out from the soil. Separating closely spaced hues like this is something that happens naturally in LAB and is hard to do any other way. And as a side note, your visual system does the same thing, which is the basis of some optical illusions, and it's why photographs do not always resemble what you saw. Now, how would we adjust color balance in LAB the way we did with RGB curves? Remember that the center point of each curve is gray, and we were careful to fix that point before we started adjusting the saturation. To adjust color balance, we move the center points. Let's run the action to create another curves layer. Now let's warm the image like we did before. Remember, hot air rises, so to warm the image, we'll raise both curves. Let's start with the B curve. Select the center point and use the arrow keys to raise it. Now do the same to the A curve. Now the image has almost a sepia tone to it. Maybe reduce the effect a little. When the expected adjustments are small, as with what we just did, one trick is to reduce the opacity of the layer first before making the adjustments. Adjusting color balance with opponent colors may seem familiar because some color balance controls do the same thing by presenting a circle with the opponent colors on each axis. Photoline has something similar: layer, new adjustment layer, color correction way at the bottom, but it's parametric for each axis. Green, red, blue, yellow. Look familiar? So much for LAB. We spent more time on color theory this time because LAB is not very intuitive, and understanding how it works under the hood makes it easier to use. And that's it for our Curves video series. Like and subscribe to the channel if you like what you see. Visit pl32.com to download Photoline. Visit russellcottrell.com/photo/photoline for a more in-depth tutorial on photo editing. And thank you very much for watching.